Sure. Okay. Loss of refraction. Beta. What do you mean by refraction, beta? Anyone? The bending of the light when it is entering from one medium to another medium is known as of your refraction of your light. Bending of your light when it is entering from one medium to another medium. Bending of light is known as of your refraction in a simple word. Okay. In this one also, beta, incident ray, refracted ray, normal ray. All of them will lie in the same medium. Like say, for example, this is your medium and this one is your normal. Okay. And this is having a refractive index mu1. And this is a refractive index of your mu2. When a ray of light is coming from your rarer medium to denser medium, this is your incident ray. The ray of light will bend towards the normal. This is known as of your refracted ray. Okay. This is your angle of your incidence I, and this is your angle of refraction R. This is your incident ray, and this one is your refracted ray. Okay. And this one is your rarer medium, and this one is your denser medium. Okay. So whenever a ray of light is going from one medium to another medium, it bends towards the normal when it is moving from rarer to denser. When I'm going from denser to rarer, it will move away from the normal, like say like this. This is your normal. If a ray of light is going from your denser medium like this is your angle of incidence. This is your denser medium, and this is your rarer medium. It will bend away from the normal. This is your refracted ray. This is your R. Am I clear? So in this one, angle of refraction is greater than angle of incidence. In this one, angle of incidence is greater than angle of your refraction. Clear, beta? What is the formula we have been using for the refraction, beta? First formula, you tell me. Snell's law. What is the Snell's law? Mu1 into sine of your I is equals to your mu2 into your sine of your R. This is your Snell's law. Okay. Condition. If mu1 is greater than mu2, in this case, light will bend towards normal. Clear? The same way, if mu1 is mu2, sorry, but this one. If mu2 is greater than mu1, then light will bend towards the normal. The same way, if mu1 is greater than mu2, in this case, light will bend away from normal. Not all drawn here already. When your ray is going from rarer to denser, it bends towards the normal. When I'm going from denser medium to rarer medium, it will bend away from the normal. In this condition, angle of refraction is greater than angle of incidence. In the first case, angle of incidence is greater than angle of your refraction. Am I clear, beta? Sure. Tell me the answer for this question. If the ray of light is going like this, roughly, and this one is your normal, and the ray of light is going from the rarer medium like this. And this is your angle, say for example, 60 degrees. It will bend towards the normal. So this will be your refracted ray R. This is mu. Mu is equals to like say 4 by 3. And this is mu. Mu is equals to like say 5 by 2. Now my question is find angle of refraction. Find angle of refraction. This is the question. Can anyone do it? The ray of light is going from your which medium, beta? Mu by 3 is greater than or 5 by 2 is greater, beta? You're coming from rarer medium to denser medium. So I can apply the Snell's law. Mu1 into your sine of your theta 1 will be equal to your mu2 into your sine of your theta 2. Mu1 is how much for me? 4 by 3 into sine. Angle of incidence is how much for me? 60 degrees. That is equals to your mu2 is how much for me? 5 by 2. So this is mu1. This one is mu2. This one is sine of your theta 2. Theta 2 is nothing but equal to your r. So from this one I can write sine of your r is equals to how much it will be better? Sine r is equals to this 2 will go here. 4 2 is a 8 divided by 5 3 is a 15 into sine of your 60 degrees. So this will be equal to 8 divided by 15 into sine 60 is how much for me? Root 3 divided by 2. 2 ones are, this one is 2 fours are. So obviously it is 4 into root 3 divided by 15. This is your sine r. So sine r I am getting is equals to how much better? 4 root 3 divided by 15. So r will be equal to your sine inverse of your 4 into root 3 divided by 15. This will be your answer, sir. Got an idea how to apply this one?
Yes, sir.
Sure. One more question faster. Like say for example, when a ray of your light enter a medium of refractive index, say for example mu. Okay, it is observed that angle of refractive index is half of the angle of incidence of your angle of incidence. Okay, then angle of incidence is, shall I try to do it? First option is 2 times of your cos inverse mu divided by 2. Second option is cos inverse of mu divided by 2. Third option is 2 cos inverse of mu. And fourth option is 2 times of sine inverse of mu divided by 2. Clear? The question is, when a ray of light is entering a medium of refractive index mu, it is observed that angle of refractive is half of your angle of your incidence. Anyone better? Something is in the question, I think. No? Ray of light is entering a medium of refractive index mu. It is observed that angle of, I'll take this one as a refraction, not refractive. Angle of your refraction is half the angle of your incidence. That means R is equals to half the angle of incidence. So angle of incidence will become how much for me? 2 times of your R. Now you get this. Okay. Now apply the Snell's law, beta. So if I'm applying the Snell's law, when I'm moving from one medium to another medium, so it is mu1 into your sine of your I is equals to mu2 into your sine of your R. Right now for me, wait, beta, air, nothing is being told. So it I'm taking for the air 1. Sine of your I value is right now for me 2R is equals to mu2. Mu2 is nothing but mu into sine of your R. R is nothing but equal to your how much for me? Same as that of your R condition. Clear, beta? I need to calculate what, beta? Angle of your incidence is how much is asking. Okay, so when a ray of light is entering a medium of refractive index of refractive index mu, it is observed that angle of refraction is half of the angle of incidence. Then angle of your incidence is how much for me? Angle of incidence is 2 times of your r. That means I need to calculate first the value of your r from this form. So simplify this one. For a, refractive index is 1. This is in the form of sine 2 theta formula. What is sine 2 theta formula, beta? This one is 2 sine r into your cos of your r is equals to mu into your sine of your r. Is anything is getting cancelled, beta? This sine r will get cancelled. So this will be equal to your 2 into your cos r is equals to your mu. That means cos r is equals to your mu divided by 2. So r will be equal to your cos inverse of your mu divided by 2. So this is your angle of your refraction. Is asking the angle of incidence. So angle of incidence is 2 times the angle of your refraction. So that is equals to 2 times of your answer is cos inverse of your mu divided by 2. So this will be the angle of your incidence. Am I clear with this one? Any
Yes,
doubt?
sir.
Am I clear with everyone? Sure.
Sir, we can't do by directly applying I by 2 instead of R.
Directly?
I by 2 instead of R.
Instead of r, I by 2 in the place of r. You can't do it out because you don't have the again the formula of I by 2. It will become still complicated.
Yes.
Okay, sure. Next one, first one, TIR. TIR. What do you mean by TIR? Total internal reflection. Total internal reflection. What is the condition for the total internal reflection, beta? Anyone? Condition. TIR होने के लिए condition क्या होना चाहिए, beta? What should be the condition? Light should always move from which medium to which medium? Denser medium to rarer medium. That is the condition. Light must go from denser medium to your rarer medium. This is the condition you need to remember. Okay. See here. If angle of incidence, if I is equals to the critical angle, then by default angle of refraction will be 90 degrees. Theta c is nothing but what, beta? Critical angle. At critical angle, angle of refraction will be your 90 degrees. Clear? Now this condition you remember. If angle of incidence is greater than critical angle, in that case, what happens? Light will reflect back. Light will reflect back into same medium. Am I clear? Okay. And again, the loss of reflection will be applicable. In the same condition, if I say that angle of incidence is lesser than critical angle, then what happens? Light will refract. Light will refract and loss of again refraction will be applicable. Clear? What is the condition? If I is equals to theta c, then angle of refraction is 90 degrees. If I is greater than critical angle, then what happen? Light will reflect back into the same medium. Okay. In the same way, if angle of incidence is lesser than critical angle, then what happens? Light will refract in the same medium. Okay, that means refraction, not in the same medium. It will be getting refracted. Am I clear? So what is the condition for TIR? Angle of incidence must be equal to critical angle. That means if I draw the roughly the diagram for this one, this is your medium, this is your normal, this is your denser medium, and this is your rarer medium. A ray of light is going from denser medium like this. So if this angle is equals to critical angle, that is I is equals to theta c, refracted like this. So this angle of refraction will be equal to 90 degrees. Am I clear?
Yes, sir.
Sure. Now written the cases here. When the TIR will take place. If angle of incidence is greater than critical angle, then TIR will take place. If angle of incidence is lesser than the critical angle, then refraction will take place. Clear, beta? Am I clear with this one?
Yes, sir.
Shit. Okay. Sure. Take one example, beta. Say for example, this is your medium, this is your normal. A ray of light is been incident on this one. This is your angle of your incidence. This angle is nothing but from your critical angle theta c. And you know that it is getting refracted. So here it is getting refracted. So angle of refraction is equals to 90 degrees. Okay. I need to calculate, find the critical angle here. Find the critical angle. Theta c is equals to how much? Can anyone try this one? Apply the Snell's law again. You're going from this medium to this medium right now for me. So from which medium you're going? The refractive index of this one is mu. And the refractive index of this one is right now for me 1. So you're going from the denser medium. So it is denser medium mu into sine of theta c is equals to rarer medium refractive index 1 into sine of your r. R is equals to 90 degrees. So mu into your sine theta c will be equal to your how much for me? 1. So sine of your theta c will be equal to 1 by mu. So critical angle will be equal to how much better? Sine inverse of your 1 by mu. This will be the critical angle formula. At sine theta c is equals to 1 by mu. Am I clear? Now tell me in the colors, if I take a colors right now for this one, that is nothing but your VIBGR. Violet, indigo, blue, green, yellow, orange, and red. Remember that for violet, critical angle is minimum. Critical angle is minimum. And for red, critical angle is maximum. That means I can say that as you're moving from violet to red color, critical angle is increasing because wavelength is increasing. If wavelength is increasing, refractive index will be decreasing because mu is inversely proportional to your wavelength. One more definition for refractive index. What is it? Mu is equals to speed of light in vacuum. Speed of light in vacuum divided by speed of light in medium. Speed of light in medium. Okay, means mu is equals to c by v. C of any of constants, so mu is inversely proportional to velocity, and that is inversely proportional to n into lambda. That is the reason we're saying that mu is inversely proportional to lambda. Frequency will be your constant. Am I clear? Am I clear? So what is the one more definition
Yes,
for the critical angle? Mu is equals to speed of light in vacuum divided by speed of light in your medium. Or from the Snell's law, we know that mu is also equal to your sine of your I divided by sine of your R. This is also one more definition for your refractive index. Clear?
yes, sir.
Critical angle is minimum for violet color. As you're moving from violet to red, critical angle will be increasing because wavelength is increasing. Isn't what is the wavelength of your violet beta? Some around 4000 angstroms. And this will be some around 7000 angstroms. So wavelength is increasing. So wavelength is increasing. What happened to frequency? Frequency decreases. Sure. Frequency will change if and only if the source is changing better. Try to remember that one. Clear? Sure. See this question, but everyone. This is your surface. This is your normal. A ray of light is going here right now. This angle is right now for me critical angle. And it is getting refracted here. So angle of refraction is equals to 90 degrees. This one is air. For air, refractive index is equals to 1. And it is denser medium. For denser medium, refractive index is equals to 5 by 3. So now find critical angle. Anyone? Theta C will be equal to how much? चलो जल्दी करके बताइए. Apply the Snell's law from denser medium to rarer medium. So for denser medium, it is mu into sine of your theta C is equals to refractive index of air into sine of your R. So refractive index of medium is how much for me? 5 by 3 into sine of your theta C is equals to air is 1 into sine of R. R is 90 degrees. Am I clear? So now simplify this one. So 90 is equals to how much for me? 1. So theta C will be equal to how much beta? Sin theta C is equals to your 3 by 5. So theta C will be equal to how much for me? Sine inverse of your 3 divided by 5. This will be your answer. Am I clear?
Yes, sir.
Sure. If sine inverse is 3 by 5, what will be the angle beta? Anyone?
37.
37. Sine 3 by 5 is nothing but equal to your sine of your 37 is equals to 3 by 5. Clear? That means critical angle will be equal to 37 degrees. Clear, beta? Sure. See this question. Good question, beta. Try to do it, everyone. The speed of light in media M1 and M2 is 1.5 into 10 power 8 meter per second and 2.0 into 10 to the power of 8 meter per second respectively. Okay. Now, a ray of light enters from medium 1 to medium 2. Okay. At an incidence angle I. Okay. Stop. If they suffer TIR, total internal reflection, the value of I is I'll give the option. First one is equal or less than sine inverse of 3 by 5. Second one is it is less than sine inverse of 2 by 3. And third one is less than sine inverse of 2 by 3. And fourth one is it is equal to sine inverse of 2 by 3. Shall I try to read the question first? The speed of light in medium 1 and medium 2 is how much for me? 1.5 and 2.0. Power are same. A ray of light enters from medium 1 to medium 2 at an angle of incidence I. If they suffer the TIR, then the value of your angle of incidence is how much? Now, first, you are going from medium 1. So it is mu1 is equals to speed divided by V1. Speed of light is 3 into 10 to the power of 8 divided by, this is 1.5 into 10 to the power of 8. This one will get cancelled. So this will be 1.5 is 3 by 2. 3 will get cancelled. This will be equal to 2. The same way mu2, second medium refractive index, C divided by V2. That is equals to 3 into 10 to the power of 8 divided by 2 into 10 to the power of 8. This one will get cancelled. It is 1.5. Okay. Now TIR is happening. So it is mu1 into sine of theta C is equals to mu2 into your sine of your R. Mu1 is how much better? Mu1 is right now from the first medium it is going. That is nothing but 2 into sine of your theta C is equals to mu2 is right now for me 3 by 2 into sine. As it is undergoing the TIR, R value will be equal to 90 degrees. Sin 90 is how much for me? 1. So this value will be equal to how much for me? Sin theta C will be equal to 3 by 4. 2 will come here right now. So theta C will be equal to your sine inverse of your 3 by 4. This is your critical angle.
Second and third options are same.
Now TIR will happen at what condition better? Second option is what I have given right now. It is less than sine inverse of your 2 by 3. And you will take this one as 3 by 2 otherwise. Sure. Now TIR will be happening at one condition, but for TIR, angle of incidence must be greater than critical angle. Okay. That means I must be greater than angle of your incidence must be greater than what? I must be greater than sine inverse of your 3 by 4. So what is the answer I can write? Critical angle 3 by 4 equal or less than 3 by. The value must be equal to your. Nothing option is matching there. No? It should be greater than sine inverse of 3 by 4. What I can write here? Nothing. Options are wrong for this one. So this should be the condition better. Angle of your incidence must be greater than of your critical angle. That means I must be greater than sine inverse of your 3 by 4. Clear?
Yes,
If it
sir.
is equal, the TIR is also static. So it should be greater than or equal should be sine inverse of 3 by 4. Options are wrong for that one. Okay, leave it. This is the method. Clear?
Yes, sir.
Sure. The next one, an important one. Concept of apparent depth. Concept of your apparent depth. You already know it. If any object is in denser medium beta, like say for example, this is your denser medium, like water. Okay, like 5 rupee coin in a tumbler. And if you're seeing from the upper part, here is right now for me some 5 rupee coin. This is your actual position of this one. Okay, so this is your actual position. That means it will be representing me the real depth. Am I clear? So when you see this object from the outside, if I draw the ray diagram for this one beta, this is the ray of light, denser medium. And if I draw a normal here right now, when the ray of light is moving from denser to rarer, it bends away from the normal. If I extend this one in the backward direction, this appears for me somewhere here. Okay, so that means from here to here, this represents me your real depth. Okay. And from here to here, this will represents me your apparent depth. Okay. So condition is object is in denser medium. This is your object. And from here we are viewing it. I'm saying from where here. So when object is in denser medium, it appears to be where beta? Nearer. It appears to be nearer. From here to here, this will be representing me the shift. So how do you calculate the shift? Shift will be equal to real depth minus of your apparent depth. This is the formula for your shift. Okay. Now first calculate the apparent depth. Refractive index mu is equals to what I can write right now for me? Apparent depth divided by real depth. So real depth I am representing by h and apparent depth I am representing by h dash. Okay. So mu will be here equal to your h divided by h dash. That means mu is equals to your real depth divided by apparent depth. This is the form. Okay. When object is in denser medium and weaved from the rarer medium. So mu is equals to how much for me, beta? Real depth by your apparent depth or actual depth divided by apparent depth. That is mu is equals to h divided by h dash. So apparent depth will be equal to how much for me? H dash is equals to h divided by mu. Now can you tell me the shift formula? Shift is equals to real depth is h minus apparent depth is h dash. So s is equals to h minus h dash is h divided by mu. So shift will be equal to h common into 1 minus 1 by mu. So this is the shift. So h represents me what beta? Actual depth or real depth or thickness. Okay. So shift will be equal to how much for me? H into 1 minus of 1 by mu. And refractive index is calculated by the formula mu is equals to your real depth divided by apparent depth. That is mu is equals to h divided by h dash. Am I clear with this condition?
Yes, sir.
What is the case? This is a case number 1. What is the condition? Object is in denser medium. Object is in denser medium. Weaved from rarer medium. And weaved from rarer medium. So when you're weaving from your rarer medium, it appears to be raised. So for that one, how do you calculate the refractive index and how do you calculate the shift? Am I clear? No, next case. Case number 2. Now, object is in rarer medium. Object is in rarer medium. Like bird, rarer medium. And weaved from denser medium. Like fish. Okay. A fish seeing a bird. Example is right now for me what? Fish seeing a bird. Bird will be in rarer medium. And fish will be in denser. Clear? So object is in the rarer medium. So if I take the diagram like this for this one, this is your surface. Okay. And this is your medium. Okay. This is your denser medium. This is your rarer medium. In the rarer medium, birds are present like this. Okay. So when I'm seeing the bird right now, like say for example, this is the eye of the fish. Okay. This fish is seeing the bird. So when the fish is seeing the bird right now, it appears to be nearer or far better. This is the normal from the eye of the fish. Okay. And this is your normal somewhere here. If the object is here right now, the bird is right now here. For the fish, it appears to be far away. This is your R dash. That means from here to here, this will be your real depth. And from here to here, this will be your apparent depth. Apparent depth appears to be far. that is nothing but h dash. And this one is right now for me h. Clear? So for the fish, bird appears to be far. So at that time, how do you calculate the refractive index beta? Mu is equals to apparent depth divided by real depth. Okay, this is the form. So mu is equals to apparent depth is h dash divided by h. So apparent depth is equals to mu into h. Then what will be the shift beta anywhere? Actual bird is here right now. So this will be the shift S.
H into 1 minus mu.
Yeah. So how do you calculate the shift now right now? Shift will be equal to S is equals to total is nothing but h dash minus h. So S is equals to h dash is mu into h minus h. So S is equals to mu minus 1 into h. This will be the formula for your shift. Clear? Am I clear, beta?
Yes, sir.
Sure. So two cases right now for me. If the object is in the denser medium, refractive index is calculated by the formula real depth divided by apparent depth. And if the object is in the rarer medium, refractive index is calculated by the formula apparent depth divided by real depth. Am I clear? And here in this one, the shift will be equal to apparent depth minus real depth. And in this case, the shift will be equal to real depth minus apparent depth. I'll write this one here. Shift will be equal to your apparent depth minus of your real depth. Done, better? Am I clear?
Yes, sir.
Sure. Let's see this question better. An air bubble in a glass slab with refractive index 1.5. Okay. In the bracket, near normal incidence. Near normal incidence is 5 centimeter deep. Okay. When weaved from one surface. Understand the terminology of the question better. And 3 centimeters deep when weaved from, when it is weaved from the opposite face or opposite side. So the thickness is how much? The thickness of your slab is dash in centimeters. Okay. First option is 12. Second option is 16. Third option is 8. Fourth option is 10. First, try to understand the terminology of a question. We got an air bubble in a glass slab of refractive index. How much for me? 1.5. So let me first draw the glass slab. This one is, say, for example, for me, a glass slab. Okay.
Both are
Refractive refractive index of this glass slab is how much for me? 1.5. Okay. The bubble is somewhere here right now. Okay. An air bubble in a glass slab of refractive index 1.5 near normal incidence is 5 centimeter. That means what, better? When you're seeing from this side, this is normal incidence. This is, say, for example, X. And from other side, it is, say, for example, Y. Clear? Am I clear with this question? When I'm seeing from this side, beta, it appears to be nearer or far? This is the first surface. I'm seeing from this side. This is your bubble object. Object is in denser medium. It appears to be nearer or farer.
near,
Shireen, क्या होगा बताओ? Like this case, first case, object is in the denser medium and you are seeing from the other side. It appears to be nearer. So when it is that nearer for this side, how do you write the refractive index beta? Mu is equals to what is the formula? Real depth divided by apparent depth. Okay. I don't know the apparent depth. Real depth is how much? X. Apparent depth I'm taking as H dash. So X dash will be equal to your X divided by mu. Am I clear? Am I clear? Now what is telling in the problem? Is 5 centimeters deep when viewed from one surface. That means X dash is equal to how much for me? 5 centimeters. So X value will be equal to how much for me? Mu into 5. Real depth will be equal to mu into 5. Refractive index is 1.5 into your 5. That will be equal to how much for me? 7.5. This is the real depth. Am I clear? When you're weaving from one side, for me, it is appearing to be at your 5 centimeters. That means apparent depth is 5 centimeters. I don't know the real depth. So we are calculating the real depth. How much I'm getting? 7.5 centimeters. Am I clear? Now, second side, second surface. If I'm weaving from this side, this is my eye now. Now, in that case, what will be the refractive index beta? How much it is the refractive index? So if it is y dash is equal to how much he has given for me in the problem. Other when weaved from other side, it is 3 centimeters deep. This is 3 centimeters. Again, same formula. Mu is equals to real depth divided by apparent depth. So real depth will be equal to how much right now, beta? Y dash is equals to your y dash is equals to y divided by mu. So I need to calculate y. Y is equals to mu into real depth. Mu value is 1.5. Y dash value is how much for me? 3. 1.5 into 3 is how much beta? 4.5 centimeters. What is the total thickness beta? Total thickness means this is the total thickness.
X plus Y.
So total thickness will be equal to T is equals to X plus Y. X value is 7.5. This value is 4.5. So how much it will be? 12 centimeters. Got it, everyone? Molasa Chudana, very important model. You'll get the regular questions based upon such models. Read the question carefully once again. If you have any doubt in this one, please let me know. Everyone, first try to understand the terminology of a question. Done, beta? Any doubt in this question? Varanya? Bubble question clear under ki?
Yes, sir.
Sure. Now let us try to do some problems better faster on the refraction. I hope what are the formulas in the refraction you need to remember. One is the Snell's law. Another one is refractive index formula. Mu is equals to C by V. And another one is right now for me critical angle. What is the condition for critical angle? Ray of light should always go from denser medium to rarer medium. Critical angle is maximum for red and minimum for your violet. So as you're going from violet to red, wavelength increases. Isn't it? So refractive critical angle also increases. Am I clear?
Yes, sir.
Sure. Now come on, take a white paper and start doing the problem with me fastly. Before I complete the question, you should be in a position to do the problem. First question, see beta. A light ray falls on a glass surface. Falls on glass surface of refractive index root 3. Okay. At an angle 60 degrees. The angle between the refracted and reflected ray would be how much? First option is 60 degrees. Second option is 90 degrees. Third option is 120 degrees. And fourth option is 30 degrees. Should I try to do faster? A ray of light falls on a glass slab. This is your glass. This is your normal. A ray of light is incident on this one. This is your incident ray. So this is your incident. This is your reflected ray. Refracted ray is this much. This is your refracted ray. Okay. This is your refracted ray. This is your R. Angle of incidence is how much for me? 60 degrees. So obviously angle of reflection is also 60 degrees. So ray of light falls on a glass slab of refractive index. Refractive index of this one is given as √3 at an angle of 60 degrees. So angle of incidence will be equal to angle of reflection beta. So I will be equal to R. There is asking the angle between refracted and reflected ray. That means angle between these two. Angle between these two is equals to how much? This angle theta is equals to how much? What do? You can apply the Snell's law beta. We can apply the Snell's law for all these problems whenever you're going from one medium to another medium. The first condition you need to remember is to apply the Snell's law. So it is mu1 into your sine of your I is equals to your mu2 into your sine of your R. This is air beta. For air, refractive index is always equals to 1. So it is 1 into sine, angle of incidence is 60 degrees. Mu2 value is right now mu3 into your sine of your R. Sine 60 is how much beta? √3 by 2. That is equals to √3 into sine of your R. √3 will get cancelled. So sine R is equals to how much beta? 1 by 2. For what value of R it is 1 by 2? So angle of refraction will be equal to how much for me? 30 degrees. If R is equals to 30 degrees, the total angle will be equal to how much beta? 60 plus theta plus R must be equal to 180 degrees. So this is 60. I need to calculate the value of theta. R value I got 30. That is equals to 180. So it will be equal to how much beta? 60 plus 30 will be equal to how much for me?
90.
90.
So theta is equals to 180 minus 90. So theta is equals to how much for me?
90 degrees.
90 degrees. So angle between these two will be equal to your 90 degrees. That is your answer. Am I clear?
Yes, sir.
Chalo, one more question faster. You should involve in that one, but I'm not here to do the problems, everything. The moment I complete the question, you should be in a position to do roughly. I'm writing neatly. That is the reason I'm taking time. Isn't it? You can do it roughly and tell me the answer by the time I complete the question. Next one, better. Find the angle of incident light. Incident light so that reflected and refracted light becomes perpendicular to each other. Becomes perpendicular to each other. Okay, come on, do it. Find the angle of incident ray so that the reflected ray and refracted ray becomes perpendicular to each other. That means this is your surface and this one is your normal. So when a ray of light is incident, this is your angle of incidence. This is your angle of your reflection. This is your reflected ray. This is your incident ray. And this value will become for me refracted ray. Refracted ray. In the problem is telling that angle between these two is equal to how much better? Angle between reflected and refracted is how much for me? 90 degrees. That is given in the problem for me. Am I clear? Clear, beta? If this is your angle of incidence I, you know that this angle is also equal to your angle of incidence I. Clear? Now tell me what is the value of R? This is the value of R. I plus 90 plus R must be equal to 180. So can I write the relation right now? I plus R is equals to how much? 180 minus 90. That is equals to 90. So I plus R is equals to 90. So R will be equal to how much for me? 90 minus I. So angle of refraction is how much for me? 90 minus I. Now apply the Snell's law. So if I apply the Snell's law, when the ray of light is going from the first medium to your second medium, that is nothing but from A to some medium mu. So for A, refractive index is how much for me? 1. This is your mu2 and this is your mu1. Mu1 is right now for me A. So for A, refractive index is 1. So it is mu1 into your sine of your I is equals to your mu2 into your sine of your R. Mu1 is 1 into sine of your I. This is sine of your I is equals to, this one is mu into sine. R is equals to 90 minus I. So sine I is equals to your mu into sine 90 minus theta is how much beta? Cos theta. Theta value is I here. So mu is equals to sine I divided by cos I. Sine by cos is nothing but tan. So this is your tan I. So angle of incidence is equals to your tan inverse of your mu. This is your angle of incidence. I is equals to your tan inverse of your mu. Clear? If angle of this law is also called as Brevister's law. Clear, beta?
Yes, sir.
Sure. Refractive index of air is 1. Refractive index of glass, if it is not given, 3 by 2. Refractive index of water will be equal to 4 by 3. This values you need to remember it. Clear? Sure. Now this question you do, if you can do this one, then I can understand that you have done little bit of your understood of you this refraction concept. An ice cube has a bubble inside. Okay. When weaved from one side, the apparent distance of the bubble is 12 centimeters. When weaved from the opposite side, the apparent distance of your bubble is at 4 centimeter. Okay. If side of the ice cube is 24 centimeter, that means thickness is given. The refractive index is how much? The refractive index is equals to how much? Shall I try to do it? First option is 4 by 3. Second option is 6 by 5. Third option is 2 by 3. And fourth option is 3 by 2. Sure. Try to do it better.
Say 3 by 2, fourth option.
Which option? What's the option, Arabita?
Fourth option.
Got it, everyone? See, this is
Yes,
your
sir.
cube. This is your cube. I'm drawing here. Ice cube. And the problem is telling that the thickness of this one is 24 centimeter. And there is a bubble in this one right now here. When you're seeing from this side, it appears to be at what distance, beta? This is, say, for example, x. If you're seeing from the other side, the apparent distance of this one is, say, for example, y. Apparent distance is given for both the case. For the first case, the apparent distance is given for me as 12 centimeter. For second case, the apparent distance is given as of your 4 centimeter. So you can use directly the formula. What is that? Mu is equals to, I'll write first one here for this case. This is first phase. This is your second phase. For first phase, for your first phase. So for the first phase, refractive index mu will be equal to real depth divided by apparent depth. Real depth, I don't know. Apparent depth will be equal to x dash. So x dash will be equal to x divided by mu beta. X dash is given how much in the problem? 12 centimeters. So x is equals to 12 into mu. That is equals to 12 into mu value is given how much beta? What is the refractive index? That only we need to calculate. That is nothing but equal to your mu. So x is equals to how much for me? 12 mu. Now for second phase. For second phase also same. Mu is equals to real depth divided by apparent depth. Real depth is y, apparent depth is y dash. So y dash will be equal to y divided by mu. Y dash is given how much in the problem? 4. So y is equals to how much for mu? 4 times of mu. Okay. What is given in the problem, beta? X plus y is the thickness. That is given as 24. X value is how much for me? 12 mu. Y value is 4 mu. That is equals to 24. Clear? 12 plus 4 is how much? 16 times of mu is equals to 24. So mu is equals to 24 divided by 16. So obviously that is 3 by 2. Clear? As I'm doing neatly, that is the reason it is taking time better. Otherwise, if I need to do it literally in the 1 minute, we can solve such type of questions easily. Got it?
Yes, sir.
Yes.
Sure. Still, we are having a lot of applications beta. Like say bulb kept in a swimming pool. We need to calculate the cone and area, that all conditions but are already there in the PYQ questions. You can directly take some of the PYQ questions from this topic and try to complete out better. Refraction. Clear?
Yes, sir.
Sure. One more topic. Sure. Next one. Refraction at curved surfaces. Okay. Next, this is a curved surface. And this one is your principal axis. This is a medium mu1. This is a medium mu2. Somewhere here we are keeping an object. This is the pole P. Okay. Coordinates are 0, 0. This is the center of this curvature beta C. Normal will always pass through the center of curvature. Try to remember better. Whenever you're drawing the normal, you should always pass through the center of curvature. So this will be your normal. Whenever a ray of light from the object is incident on the surface like this. So this will be represents me the angle of incidence. The ray of light is going from a rarer medium to denser medium. So obviously it bends towards the normal. So this will be your image formation. This will be equal to your I. Object distance is represented by U and image distance is represented by V. And distance from pole to the center is known as radius of curvature. That is nothing but equal to your R. Terminologies. Am I clear? Ray of light is going from denser medium to smaller medium. Now we are talking for small angles beta. For small angles. Like 3 degree, 4 degree, 5 degree. For that cases only we are talking. In that cases, the relation for this one. I hope you remember the formula. Can anyone tell me the formula beta? Mu2 divided by V minus mu1 divided by U is equals to, what is the formula? Mu2 minus mu1 divided by radius of curvature R. Going from rarer medium to denser medium. When I'm going from rarer medium to denser medium, the formula is mu2 divided by V minus mu1 by U is equals to mu2 minus mu1 divided by R. Clear? So what is U beta? Object distance. What is V? Image distance. R, radius of curvature. Mu1 is the refractive index of incidence medium, and mu2 is the refractive index of your refracted medium. Am I clear?
Yes, sir.
Sure. I need not write the values now. What is mu1 and mu2? And wherever is object beta, that side you always take it as of your mu1. Wherever is the object, that side you take it as of your mu1 and try to do the problems. Clear? If you're going from denser medium to rarer medium, how do you write the formula, beta? I'm going from denser medium to rarer medium. What will be the formula? Same, but change the subscripts. In the place of 2, 1. And in the place of 1, you keep it as 2. So it is mu1 divided by V minus of mu2 divided by U is equals to mu1 minus mu2 divided by R. This will be the formula. Then, if you're going from your denser medium to rarer medium, just change the subscripts. That will give me the answer for it. Clear, beta?
Yes, sir.
Then how do you calculate the magnification in this one? The magnification in terms of the spherical surface is given by the formula. Remember, m is equals to size of image divided by size of object is equals to mu1 into V divided by mu2 into your U. This is the magnification. Mu1 divided by mu2 into your V by mu. Now for plane surfaces, whenever I'm talking about for plane surfaces, radius of curvature will be infinity. If radius of curvature is infinity, I can write mu2 divided by V minus mu1 divided by U will be equal to your 0. So in that case, mu2 divided by mu1, mu2 divided by V is equals to your mu1 divided by U. Or else mu2 divided by mu1 is equals to your V by your U. Done? Now see beta, in this optics, whenever I'm writing refractive index of 2 with respect to 1 means whatever is down, you need to write first there beta. Mu2 divided by mu1. Like say if I'm writing refractive index of glass with respect to air, this is the refractive index of glass divided by refractive index of your A. That sure. Take one small problem beta, first away. This is your curved surface and this is your principal axis. Okay. Somewhere here I'm giving an object. An object is at a distance of your 20 centimeter. Okay. And this is your curved mirror. Sorry, surface. Refractive index is right now here 4 by 3. And here refractive index is 1. It is air. This is the pole of the mirror, curved surface P. And this is the center of curvature C. And center of curvature distance is right now for me. From here to here, this is center of curvature. From pole to this surface, this distance is given for me as 40 centimeters. Okay. I need to calculate position of speed. Okay. So I can write here, locate the image. Locate the image. This is the question for the object O. Can anyone try it better? From where the light is going, can anyone tell me? It is going from rarer medium to denser medium. So ray of light will go like this. It will bend and it will incident somewhere here, right? So roughly. First, let me draw the normal for this one. Then we will get a clarity. For the normal, this will be the norm. So from this one, the ray of light will incident on this one and it will bend towards this one. So this will be the image formation. This is I. So from the pole, what is the image? I need to calculate this V is equals to how much? The ray of light is going from denser to rarer medium. So I can write the formula mu2 divided by V minus mu1 divided by U is equals to mu2 minus mu1 divided by radius of curvature R. So this is mu1, this is mu2. Mu1 is how much for me? 4 by 3. Image I need to calculate minus mu1 is 1 divided by object distance. All the distances are to be measured from the pole. So as you're measuring opposite to direction of light, it will be equal to your minus 20. That is very important. That is equals to 4 by 3 minus 1 divided by radius of curvature is how much for me better? 40 centimeters. Am I clear? So if I simplify this one, this is 4 by 3 times of V minus of minus, it will be plus, it will be 1 by 20. That is equals to 4 by 3 minus 1 will be equal to 1 by 3. 1 by 3, 3 will come down, 4 3 is 12. So it will be equal to 1 by 120. So this value here it is right now for me how much? 1 by 3 divided by 40. So that is equals to 1 by 3 into 40. That is the reason I'm getting as 120. So 4 divided by 3V will be equal to 1 by 120 minus 1 by 20. So it is 4 divided by 3V. Take the LCM for this one. It will be equal to 120. And this will be equal to your 5, 2, 10, 9. It will be equal to minus 5. Okay. So V will be equal to how much better right now for me? So what is the value of your V? So V is equals to, see how much I'm getting?
minus 32.
It is 120 into 4 divided by, this will be equal to your minus. V will go up 3 into 5. Done?
Yes, sir.
So how much I'm getting this one? This is 3 ones are 3 fours are 40. 4 fours are 60. That is 160 divided by 5. 160 divided by 5 means 5 3s are 15 minus. It will be equal to 1. That means 32. It will be minus of 32 centimeters. So image is at your minus of 32 centimeters. Clear? That means if the image is negative, that means where is the image? On the other side or on the same side as of your object?
Same side.
Yeah. So then the image will be somewhere here, right? Okay. So image is formed at the 32 centimeters on the same side of your object part of flush. Am I clear?
Yes, sir.
Sure. We'll try to do some more problems based upon the refraction surface in the tomorrow session of your class. You just remember the magnification formulas and as well as of your basic conditions. Magnification formula is how much better? M is equals to your mu1 divided by mu2 into V by U. That is very important. Remaining formulas, anyhow, this is a general formula only. When you're going from rarer medium to denser medium, mu2 divided by V minus mu1 divided by U is equals to mu2 minus mu1 divided by your R. Okay. The same way when you're going from denser medium to rarer medium, just change the subscripts. That will give me the formula. Right? And please try to take the PYQ booklet and try to do the problems on the refraction at the spherical surface. Don't be in hurry to do the problems of lens makers formulas and cutting of lenses. Refraction के भी थोड़े अच्छे खासे problems है with your optical fiber. That all. You just try to go through the basic condition and try to do the problems. Okay, na?
Okay, sir.
Yes, sir.
Tomorrow is Sunday. I'll update you the timings related to the tomorrow section. Tomorrow we'll be taking the class somewhere in afternoon hours. Evening, I'm already preoccupied with some other classes from 5 to 7. If it is possible, I'll try to take 7 to 8:30 or 10 to 11:30 as usual. Morning, there will be no class tomorrow. Okay, beta? Notes చదువుతున్నారు
Okay,
రోజు
sir.
పంపించేది మీరు నేను ఫాస్ట్ గా రాస్తున్నాను సో దట్ ఏదైతే అవసరం ఉందో దట్ ఓన్లీ ఐఎమ్ డూయింగ్ సి ఐఎమ్ నాట్ టచింగ్ ఎవ్రీథింగ్ విచ్ ఇస్ దేర్ ఇన్ ద సిలబస్ because there are some areas where it is of just for teaching and it is we never got the questions in that areas that I'm not touching. Like say in this one, I have not touched the lateral displacement at all. For that JEE mains all, that is very important area. But for NEET, I don't think so that much. But the concept of this refraction and reflection with this basic Snell's law application is more. In tomorrow's session of your class, we'll try to do some more problems on the fish and bird problems and some of the problems related to your refraction at the curved surfaces with magnification. Then we'll try to start with your prism, and we'll try to keep full stop for the prisms and as well as of your lens makers forms. Okay, na?
Okay, sir.
Sure. Take care, beta. Bye. And please try to complete the PYQs better. Ray optics and electrostatics, electric field and potential, you try to complete it out. Okay. Bye.